Hi guys, in the last video I introduced you to a general idea about what exponential functions actually look like. And now what I want to do is I want to have a look at some transformations of these particular exponential graphs. So I've got two graphs here. I've actually got one laid on top of the other. So I've got y is equal to 2 to the x, which is in red, which is covered by my other line, which is y is equal to a to the x. And in this case I have a set as 2. So if I was to manipulate this variable a and I was to increase this variable a, what do we think would happen to the curve, this curve here? Do we think it would become steeper or do we think it would become flatter? Well, having a look and going through and seeing what's happened for parabolas, I'm going to predict that this is actually probably going to get steeper as it gets, this value for a gets higher and higher and higher. So we can see here now, this blue line, it's moving closer and closer and closer towards that y-axis, okay? So this is actually getting steeper as it gets closer and closer to infinity. So we can write some of these rules. Let's summarize some of these rules. So I've got two graphs here. I've got y is equal to 2 to the x, which was my original red line, and y is equal to 4 to the power of x. So that's increasing that value of a. So when a is close to 1, so that would be quite flat here. And as it increases, it's getting closer and closer to that y-axis, so it's becoming steeper. So what happens to this graph when we sort of start to go the other way now? So we're looking at values of a that are going to actually be less than 1. So we can see here that this curve is flattening quite significantly now that it's getting closer to 1. What happens as I breach this sort of point and I go below that? So from the points of 0 to 1, so when a is equal to some sort of fraction. Well, when a is equal to some sort of fraction, it actually flips flips across the y-axis, and I'll show you why that's the case. So you can see here I've got the graph of y is equal to 2x in red, excuse me, and I've got y is equal to a half x here in blue. And really the reason that this is happening is because when we have a fraction, if I was to write 2 to the power of -1, that's the same as saying to the power of a half. So a fraction has a negative index. So really I could actually rewrite this as y is equal to 2 to the power of negative x. So it's reversing all of the x values. So for example, this value that was at -10 is now at +10. So it's literally flipped across that y-axis. So we know that because it's exchanged the x values. So keep that in mind, because if we have something that is making x negative and it's flipping across the y-axis, how do you think we're going to get that transformation across the x-axis? Let's keep investigating. So we've seen what happens now when we have a is equal to a fraction, so between 0 and 1. What happens as we continue to decrease this value? Well, as we decrease this value, you actually see that this curve begins to stop existing. And I'll sort of explain what's going on there. So let's say I was to take a value, and let's say I was to do just like -3, for example. If I did -3 to the power of 1, that's going to be -3. If I do -3 to the power of 2, that's going to be +9. If I did -3 to the power of 3, that's going to be -27. And so this graph is constantly flip-flopping between having positive values and between having negative values. Also, if I was to try to raise this to the power of a half, so in other words, the square root of -3, I wouldn't actually have a value. So this isn't really a function that we can define when values of a are negative. So I'm going to manipulate this expression a little bit. And what I'm actually going to do, I'm not going to put any negative values of a, I'm going to put the negative out the front here. So when we read this, really what we're doing, imagine that there's a pair of brackets that's wrapped around this a to the power of x, and we're just making that negative. Really, if I wanted to, I could rewrite this as -y is equal to a to the power of x. So what did we sort of explain was going to happen? If we were to make y negative, that's now going to reflect across the x-axis, because all of these values that were positive are now going to be in the negative. So I'll show you what I mean. I'll add a slider in here. And so if I was to if I was to change these values, so this value is greater than 1, then we can see that this is the exact opposite. It's just being flipped across the x-axis now. So again, if I was to change this into a fraction or a decimal, we can see now it's reflected across the x and the y-axis. And if I was to make this value a negative, regardless, it's not going to appear. So let's write this in our rules. So now we have our vertical reflection, so our reflection across the x-axis. And this is specifically when we have this negative value out the front of the a. So it's really essential that we remember those brackets as if they were wrapped around that a to the power of x. Now there's one more that I wanted to have a quick look at, and that was the vertical and horizontal translations. I think we might leave the horizontal translations for a bit, but I'll show you a vertical translation. So as we've probably seen a few times before now, with linear functions and with parabola functions, quadratic functions, when we add this value on the end here, all it does is it just shifts the entire value of the graph up by that amount. So again, I've got my curve y is equal to 2 to the power of x in red, and this is just sitting behind this blue curve at the moment. So I've got my a to the power of x set to 2, and then we're going to manipulate this value for c. So you can see this curve moving up as we increase the value of c, and then moving back down again as we decrease the value of c. So this is our vertical translation for exponential graphs. So there we have it. So those are our 4 different transformations that we're going to focus on for exponential graphs. So we've got our vertical translation. So that's defined by that factor c. So I'm going to actually write this equation over here so we can see what I'm talking about. When I've got y is equal to a to the power of x plus c, this value c is going to shift that graph up or down. So I've got the graph of 2x plus 5 here, and you can see that this has been shifted up 5 units. But other than that, it's the exact same graph. When c is negative, so when c is less than 0, this is going to shift the graph down. Going back up now, just to refresh, we have our vertical reflection. So that's when we have our negative a to the x. And again, the way that this works is that we've almost like wrapped some brackets around this a to the power of x and just put the negative in front. So it flips the entire graph across in that vertical direction. So across the x-axis. Then we also have our horizontal reflection. So that's our reflection across our y-axis, and that's when we have a negative value or a negative power for x. And then the first transformation that we looked at was the dilation. So we saw before, as that got bigger and bigger and bigger, the graph became steeper and steeper and steeper. So those are our 4 transformations of exponential graphs. So in the next video, we'll have a look at solving some problems. See you soon.